on the second page of our Unit 5 notes, we are looking at solving a system by graphing. When we are solving a system by graphing, we are graphing each of the lines in the system and then looking for the intersection point. The first step is to write each equation in slope-intercept form, which has already been done for us in the first example. And we're going to go ahead and graph both lines. Y equals negative 1/3 x plus 2. I'm going to put a point at that start value of 2, and then use the slope, negative 1/3, to go down 1 over 3, down 1 over 3, up 1 back 3, up 1 back 3. Try to draw a line. So I'm going to draw the line using the line feature on this software program, but I can't draw arrows on it, so, well, I can right here. Okay, so that's the line y equals negative 1/3 x plus 2, and then the second line has a start value or a y-intercept of negative 3 down to over 1. And you can see why we got really good at going backwards, left 1 up 2 during Unit 2, because that's what we need to do to find this intersection point. So we want to be really precise with the lines or with the ordered pairs that we're plotting. And then the solution is that intersection point. Negative 3, 3. Really common for students on assessments to graph the two lines, but then to forget to answer the question, which is, what is the solution to this system? The solution to this system is the ordered pair that makes both equations true, or the point that is on both lines, which is the intersection point. When you are solving by graphing, I highly recommend, even though I don't usually require, that you plug that ordered pair back into both equations and make sure that it does make two true statements, that it is in fact a solution to both equations. That helps you make sure that you didn't make a mistake with graphing. So negative 3, 3 is a solution to that first equation. Let's see if it's a solution to the second one. 3 equals negative 2. 3 equals 6 minus 3. Yep, 3 equals 3. That shows me that I didn't somehow graph this incorrectly, that negative 3, 3 is a solution to both equations and therefore to the system. For the second example, I have a start value of 4, a slope of negative 1/2, so down 1 over 2. Rise of negative 1, run of 2, rise of negative 1, run over 2. So I can think instead of a run of negative 2, rise of 1. That first equation was already in slope-intercept form, so no problem there. The second equation is not in slope-intercept form, and the directions say that you should always write both equations in slope-intercept form. It actually would be okay in this case to graph by intercept, so keeping it in standard form, x-intercept of negative 4, y-intercept of 2. This is just not generally the best strategy, because if the intersection point were far from the x and y intercepts, that wouldn't be a very precise line since it was only graphed from 2 points. So in this case, it would be okay, but it's usually better to, instead of graphing by intercepts, to transform the standard form equation into slope-intercept form. So slope-intercept form of this equation is y equals 1/2 x plus 2. 2, up 1 over 2, up 1 over 2. We could have also used these 2 points to figure out the slope and just continue the pattern. Here, the intersection of these two lines is the ordered pair 2, 3, x equals 2, y equals 3. Let's check that that is in fact a solution to the system. So negative 1/2 times 2 is negative 1, plus 4 is 3. And then 2 minus 2 times 3, 2 minus 6 is in fact negative 4. That means the ordered pair 2, 3, the point 2, 3, is a solution to this system. Again, it lies on both lines and it makes both equations true.